guys, welcome to the Tool Shed.
Hello, everybody.
It's Jerry and I. Jerry's dialing in from Brisbane. Whereabouts are you in Brisbane, Jerry?
I'm on
Queensland?
the Sunshine Coast, but out to the west, I'm on a mountain called Clear Mountain. It's a Mercure hotel, and I'm having a look at that for an investor. But it's a good job, but Tool Shed's more interesting.
Excellent. So yeah, Andre, Doug, Gary, and Chris, Mark, Paul, thank you for joining us. So we're going to jump in today. We'll be talking about cladding essentials. This is also an opportunity for you guys to throw some questions at us. So if anything comes to mind, throw them and we'll do our best to answer them in this time we have together. And if we don't, we can always come back to you.
And it's collective brains trust approach. That's the whole idea with tools, with the Tool Shed.
Brains trust. I like that. Drop us a note also if you on where you're dialing in from, if this is your first time and what your role is. It'll help us cater the conversation as well. But let's jump on. And before we go into cladding, I did want a little bit of a current affair. This is not so current. I think we're all very aware of the housing crisis and that Australia is facing. 1.2 million homes. We've got low completion rates. 90,000 extra construction workers needed. So you put that amidst the material costs and the trade shortages, there will be a massive focus on speed. And so my question to you, Jerry, and to the rest of us here is, at the expense of, with a focus on speed, will there be an expense on quality? We're going to forego quality. Because you said this, Jerry, that governments could save at least $100 billion when building its target of 1.2 million houses.
I can't see that screen, Siva. Yes, but I think there's a real risk that we're not fessing up and facing the real problems, which is getting people up to speed to build well, and not have the complaints and the downside risk of the buildings being delivered and handed over with this again legacy of bad quality work.
Yeah, absolutely. And a lot of the issues that we're seeing on site are not because people go to work to make mistakes. They go to work, they're aiming for speed. They just don't know better. And inevitably a defect is either happens at a design stage or at a delivery stage. Just confirm you can see my screen now, Jerry?
No, I can't, but that might be me remotely. But I'm going to say to the group,
if there's someone giving me a thumbs up or something, just confirming you can see my screen.
Speaker view, no.
Yep, I got it. Thanks, P. Thomas.
Review.
This was just a little bit of a thought provoker that we're all in this, and as far as the construction industry goes, and getting some of this knowledge, some of these essentials that we're going to be talking about, and making knowledge easily accessible. Jerry and I are very excited to be talking with some of the teachers at TAFE New South Wales, and they're looking at rolling a product like tools out across all of their classrooms, just to make knowledge easily accessible. So that's exciting. So if you can, you guys use.
Siva, I'll bring you back to that question. The question I've been asking the cohort of many of the people that are listening today is that most of us would be, I'd be really ashamed of a serious defect. I hate it. I just can't remember making a serious defect on my watch, or having somebody that is working with me make a serious defect when I've been working alongside them. So, and if I did, I would be humbled, I'd be ashamed, and I'd fix it up. Minor defects, I'm just embarrassed by them. But we go back and fix it. I imagine that everybody sitting in this shed today, we're so used to going back and fixing this stuff. We don't need insurance. We don't need conflict. It hasn't affected program. Ideally, we've prevented it because of our knowledge base and our commitment to craftsmanship and just the joy of going to work and hi-ho building really well. And yet we've got this industry that seems to want to have defects created, leaky buildings, and then the downstream problem. And they're expecting us to build 1.2 million houses with kids who don't know squat.
Yeah. And unintentionally, right? So this is a product of where we're at.
They're good kids. They just need.
Yeah, absolutely. So let's focus on knowledge. So cladding essentials. We're going to cover a few things today. Purpose and types of cladding. But back to some basics. Principles of keeping buildings dry. Jerry will then go into some specifics, and we'll jump in between some of the tools that we've got in this. the devil is always in the detail and some of the maintenance elements that you need to be aware of. But Jerry, if we start off with what is the purpose, other than to look nice? You know, we've got a few buildings down the road from where I live, and they look fabulous with new cladding. But other than the cosmetics, what is the purpose and the different types?
Look, all of you are getting to know me by what I deliver. I try to simplify things. I don't like talking. I've got Siva there, who's got a much better tongue than I have for explaining this. I look at the cladding as being the skin. It's essentially the skin of the building. It doesn't matter what type of cladding you have, but there are lots of different types. There are the old weatherboard type that some of the older people there are used to. Now there are artificial versions of that. There's lots of fibre cement cladding. The metal cladding that is now around, if properly detailed, one, it can look exquisite. It can be aged. It can be rustified. It can be metallized. You can have beautiful finishes there. The ACP is being replaced by full aluminium panels with its new set of problems. All of it is just essentially a skin on top of either the thermal components that we need to get right for the area and also the vapor barrier that needs to go on to make sure that we deal with condensation and our building breathes.
Just a very quick thing for your tools users. Hopefully you've jumped into tools before and this is not your first time, but just remember their mantra of find, zoom, share. So if you're looking to implement something onto documentation or share it with a trade or with a colleague, find the tool, zoom in, and then if you generate a share link, if you can generate it in two places, up along the top here, and that'll share the entire tool. If you share it out of a side panel like I am on the bottom left here, it's a bit small, and I'll share that in our chat. That will, when you click on that, that'll pop the side panel out, so the recipient will see the same view. So we've talked about a little bit of the types. You mentioned it's all about where you're at, cladding appropriate to where in Australia you are, if that indeed is where you're located. This matters, right, Jerry? Climate.
It does, and maybe I'm some simplistic. There's going to be a different thermal load. There'll be a different heat, a different cold. There'll be different humidity where you live, and we should be taught this. And you guys have been seeing, and girls have been seeing our science of. We're probably going to do a science of location and weather, so that we're going to be making really informed decisions. So that if we do we go up to help our daughter up in Townsville, you've got different thermal requirements there. You've got much different humidity requirements. The science, however, of putting a cladding to your back end thermal products and humidity products remains the same, and that's probably what I want to get across today. Cladding is cladding is cladding, and the detail that we're going to talk soon about and the science of drainage remains the same wherever you are, but the back end that we're covering is really, really important to get the performance and comfort in your building.
Yeah. So this particular tool, the climate weather map, I'll generate a share now, but it's under comfort. And let's talk about, Jerry, the principles of keeping a building dry. Let me just share this with our group here.
We hear the term leaky buildings and everybody's whinging and the commissioner's saying this and you've stuffed up again, and there's developers in the media. No one's telling us why. So AJ and I, with Siva's guardianship, we've done the science series. It's called Drainage Science, which Siva's just going to put to screen.
So that's under skills.
Skills under science of and drainage. Now, one of my mates, the Brains Trust, of course, reminded me I hadn't put deflection. So this has got. I'll go through the basic Newton's law stuff. You see how I always put set downs in buildings, and sometimes it's unusual, but I'd like to think that that's still possible. I like set downs. I like the base of even frame walls to go into a set down. Often that's not possible, which is where you can still get capillary barriers. You can still get that if you go up there, you'll see an overlap drainage. So this is all Newton's law. Water goes downhill. Everything is on the outside of the item below. The overlap is always as per the manufacturer's requirement, which is normally 50 mil in my experience for sarking. They're taping it a lot now. There'll be some skills that I don't know. I'd have to probably look at the technical information. I don't like side laps in sarking unless it's really carefully done. I normally go across two studs. When I take sarking around a corner, I always wrap it round the corner. I never cut it into the corner. These little trade skills that I've learned from watching hundreds and also doing the work, but watching hundreds of skilled tradesmen and craftsmen doing it. So this drainage science underpins dry buildings, and it's a particularly good one for cladding.
Yeah.
But I will do this shout out. Deflection's not about cladding there, although movement's really important to cladding. So we did this drainage science, and quick as a flash, one of our brains trust sent me thing, Jerry forgot to make the deflection clear here, that you've got to make sure you put your drain in a slab anywhere. Inside, I don't think it matters, but if you're on an outside slab, you are going to get some deflection in the slab. Put the drain where the sag in the structure is going to occur long term.
So in short, the principles of what, how would you summarize that? Keeping buildings dry.
The principles of dry buildings, really, and it's anti-building therapy, whatever you all want to call this. It's just such a good way that if you understand the principles of overlaps and set downs and water draining outside the building, we don't need the term leaky building. We just need the term dry building, because we have the skill and knowledge and we're using the principles of science.
Yeah. So let's get into some specifics. What tools do you want to go through? And again, if you've got any questions or any thoughts, maybe something that you guys are coming up against, let us know in the chat.
Especially if you're doing any specialist cladding, anything that's really detailed. Some of the architects are specifying, bespoke products and funny shaped profiles. Is there anything that we can learn from what you're doing, whether they're being fixed to rondos? Are they concealed fixed? Are you having any trouble with the corrosion of rondos when board is being fitted to rondos, which always terrifies me? And I just heard of a job where a builder had installed rondos but with passivated zinc screws next to the coast, and the screws rusted in about 2 years.
Yeah. Just a quick tip in case you didn't know that all of this red-based code here, or these labels, are code-based, and you've got the little superscript there that'll give you the original citation. So we sometimes get asked, where did you get this from? So all of these are now cited, so you can just click on that. That'll copy to your clipboard. If you want to go back to your original source, you're very welcome to. So that'll take you back there.
And look at that. So there's Jerry, this so-called person who's meant to know this stuff. So I now know I'm locking in that the overlap for most of the sarking now is 150. So that's one of those sort of benchmark rules. And I just undercooked it because most materials lapped 50 mil will be satisfactory against wind pressure uplift. But the manufacturer is saying for sarking 150. So we know that that's what we have to use.
Okay. Yeah. Specifics. Do you want to jump onto the actual cladding tool?
Yeah, jump onto the cladding tool and we'll start to drill down.
Search. So let's jump into, so if I could spell correctly, cladding tool, and that's sitting under fabric in our menu. All right.
And there's some points about whether it should be called fabric, but we had to make sure that people could search graphically for this. You can search by word, you can search by voice, but I like the site search, so I use this most of the time. I just go straight to the menu and click this out. So again, you'll see the drainage science is captured here. Everything overlaps, so it overlaps onto the head flashing. The head flashing spills outside. We've got some cladding there. We haven't put the 10 mil gap from the base of the cladding to the head flashing, but all of these gaps become really important because especially if you're using metal cladding or if you're using, most of the timber now is durable, but if you're even using a class 1 timber, I like to leave gaps from direct contact with any of the flashings.
The extension beyond the reveal code is is 110, greater than or equal to 110. But just
Hmm.
for folks out there, with the blue content and blue labels is best practice. So that's based on industry best practice, and so that says 150. Do you want to talk just about best practice versus code?
Yeah, but I don't want to get into a fight that if a person's putting cladding up the whole time and they're into a rhythm and they've got their 110, 120 overlap and it's into culture as long as they box the ends. So if anybody doesn't know what boxing the ends is, you're turning it up so the water drains to the outside. It doesn't go sideways. Look, I'm not going to have a fight about that, but probably I'm a bit old school. A lot of people have taught me 150. It used to be 6 inch. It's terrible, isn't it? You've got an old man talking imperial. The dry building concept here is your head flashings and sill flashings extend past your reveals.
Yep, that's the key. Yep,
That's the key.
yep. Are you seeing a lot of issues on site
Oh,
with?
yeah. Look, it's especially they were just running the head flashings flush with the reveals with most claddings. Upwards of 5 years ago, and then I think the manufacturer started to really get serious about giving this wisdom back to the industry.
Yep.
We just got to make sure, because it's part of a side overlap, peeps that are watching this. So you've got the downstream overlap, but the head flashing needs to extend to create the side overlap. So water that's being pumped in by wind pressure in different direction hits everything, drains in gaps in the flashing, comes down, hits the head flashing, and the head flashing drains it out and drains it out to the side as well.
Yep. All right. Specifics. What else? What else you want to talk about?
Corners.
Corners.
So the devil is in the detail. So often we find that, that it took no more time. I mentioned the sarking being wrapped. I like always sort of like bandaging. I like to make sure that it's all bandaged together and there's one homogeneous film of water tightness behind with the sarking. But then on top of that, you've got the manufacturers will normally give you all their profiles. There'll be an angle, internal angle, external angle. And if I break a job apart for a court case or for an NCAT matter, we take the edge of the cladding off or put a borescope in, and you can just bet your bottom dollar that they just didn't bother. Southern face of the building, internal, second story, and they've left out the corner angle for the sake of what? I mean, they've got the material there, and they've left out that piece of corner angle.
Yeah. And what's I mean, the obvious thing is you leave that corner angle out, and then you're going to start letting in moisture. What's the material? Do you want to, in terms of the fixings of those? Do you want to comment on how
Look, the fixings depend upon the manufacturers, but most of the time, look, we know we insert it, we fix it, and then you'll find at the corner there's an external corner angle as well on the outside corner. You'll see how everything, we haven't broken that joint apart, but the corner angle again should extend down past the base of wall flashing and or the cavity flashing. It doesn't matter what it is, it's just a flashing either at the base of the wall or at wherever the architect has detailed it or the manufacturer requires it, that all of the detail above will drain to the base flashing. What we haven't shown there, peeps, is the way that looks like a miter joint for that base flashing there. So where there's a miter joint, that has to be backed up and sealed. And we haven't shown that. So that would be something that I'd be saying to all of you that you've probably all done this. It's really important that those corner joints are properly made and properly sealed. Ideally, they're overlapped. Probably for cosmetic reasons, the architects like to have that a really clean corner joint. And that makes it quite complex. But it needs to be backed up, supported, riveted, sealed on top, and then your sarking and other accessories get drained over and dressed over and drained over it.
So just a couple of tips, Jerry. Obviously, if you're doing the actual work of the installation, or you're the subcontractor, and you're pushing this down, you can share this with or review it yourself. But if you're in the design space and you're wanting to specify this, and you're wanting to then share this with a contractor who's doing your work, you can just generate that share link that I've shown you. Another couple of ways you can do that is if you're a Revit user, we've got a Revit add-on where you've got the Revit Marketplace, you can download tools. We are asked often about when's ArchiCAD coming, and that is on the to-do list, but apologize, it hasn't been done yet, but that's coming soon. You can drop these spec blocks onto your drawings, which can then, if the plans are printed out, someone can scan the QR, and so you can drop these or into a report, you can drop it into an email. So that's a handy gateway to this tool. And you can also download the PDF, right? So if you want to include this as part of in your document pack, you can download the PDF, and I've got one I baked earlier. So that's an example of what it looks like. Again, if it's printed, people can scan it, or you can just click and that'll go to that tool. So it's a couple of different ways you can.
Now, if you're a contractor and you've got some, friendly designers and architects there, and you're just saying, and the architect's saying, I want the relief. So they want that, they want the base of wall flashing to come out 25 mil to give it that punchiness. And so you'd send off that detail to the architect and say, look, as long as we can drain our sarking and our material across, obviously, and this is feedback for us too, Siva, we haven't put a very slight slope on that base flashing at the base of the wall.
Mm-hmm.
And it does not need a slope on the horizontal portion of it underneath the cladding and or the sarking, unless it's probably more than 50 mil. Mm-hmm. But if it's more than 50 mil, it's best to get it folded with a slight slope. Again, we're using gravity the whole time, and we're thinking Newton's law, and we're thinking dry building. If it does hold water, it's not going to cause trouble if it's aluminium, but it's certainly going to cause trouble if it's a zinc aluminum and or a ColourBond product. And I want to see the cheapest and best products being used, and there's nothing that stops people using, especially ColourBond, as long as it's not close to the sea.
Yep. The devil is in the detail. So any specific things you want to call out? By the way, on each of the tools, just take note of the related links. So if there's a tool, so for example, you can switch here to masonry veneer. Same tool.
Same principles. So you could almost look at brickwork as being a cladding material, same principles.
Yep. Devil is in the detail. Jerry, any specifics you want to call out?
I think it's just you all seeing that if you have got a masonry job and you're getting a feature wall done in masonry, there's thousands of years of knowledge about masonry cladding on a brick veneer and or full brick building. Please revert to that. Get your weep hole spacing. And if you're a perfectionist like me, I always gauge, and I always put my weep holes vertically above each other. I set them out logically. So even though, as long as it's no more than 5 courses, I want to get them equal spaced. I don't like weepers. I'm sorry. I don't like weepers. I don't like the look of them, but if you want to use them, you can. I just like open, clean joints. And I don't like painted brickwork, so in detail. But look, this is not so much of as an importance to cladding besides the bushfire. If you go to bushfire, if you're putting cladding up in bushfire, you've got the link on the side there. Siva, just go to bushfire construction.
And there's a lot of fire tools in here, so if you haven't had a chance, take a look at those.
But related to cladding, I'm being quite granular here, peeps, because we're talking about cladding. If your carpenter's putting up cladding or you're putting up cladding, there are rules. There are really strong rules. So if you're in a 29, about 29, you're putting cladding up, you have to make sure that the cladding complies with all of these BAL rules that are on our bushfire tool.
Yeah.
Okay, and it's fun. It's just, and in fact, you don't want gaps. You don't want gaps. You don't want anything that can harbour a cinder or a flame. And you certainly can't have open vents. And there are certain things that you won't do that to you are standard practice because you are complying with the bushfire code.
Yeah, absolutely. So you'll see scattered around tools, if this is the first time you've seen it, these ohmmeters. And they're really a gateway that allow you to very quickly change the settings. So if you've got a 29 at one end of the property and a flame zone at the back, you can change that and all of the codes will update. And again, if you share that, the recipient will see, which I'll share now.
So here it is. You've got, the architect said, blah, blah, I want this, I want timber. And then you just say, well, no, because it's BAL 40, we have to have a fire-rated material there. And, and you haven't, the architect's showing the wrong material there, and you say, no, we need to put a sheet of 13 mil behind what you're doing. We can do what you're doing, but I'm going to get paid, Mr. or Mrs. Architect, for including what should have been there, and we will never have the Californian Marysville and Canberra fires the way you've been seeing in the media.
Yeah, absolutely. Probably a little bit off, but yeah, again, a lot of these. So we call it tools, but the best way. Every good tools, or every good tradesperson knows their tools. So get to know your tools. There's a lot of information in here. We've got about 5 minutes. Again, if there's any questions, let us know. Otherwise, Jerry, maintenance. You said there's some maintenance aspects that people need to be aware of.
Yeah, there's a couple of storylines here. So maintenance is really driven by what you choose. Now, I am pushing for a 50-year life for what we install. And anything that's concealed, I think, should have an unlimited life, which is why I've got treated timbers into culture. And I'm really, really keen to take all of the rubbish fixings out. I've always used galvanized nails. Now, nail guns have got galvanized nails. So please make sure that those things are used. When you're doing claddings, a lot of the fixings for the claddings to look nice are concealed these days. Don't just use anything. Please don't use anything that's not a high durability. And if it's within 500 meters of breaking surf, please use stainless steel or brass. Just bite the bullet and say, or give it to the customer and say, look, the cost of doing this right, because we're craftsmen and we care about your maintenance, and all of this comes to maintenance. And if I'm sure all of you have seen a rusty screw punching through the filler on your cladding, and thought, how much was the cost to do that in stainless? Square head, nice and easy, recessed in, countersunk in, bang. External filler on it, so we're making all these wise decisions. And even if the filler gets a little bit of bumping and vibration, and you see the outside line of it, you don't have to take the screw out. You'll just be basically repainting that, maybe stopping up the slight cracking, and at next repaint, it's as good as when you started. Maintenance really matters. I'm also very, very keen on the detailing of steel. Steel needs to be, ideally, a lot of vertical steel they put in contact with the base flashings. Please leave a gap there. Obviously, you've got to think about vermin, but I'm very keen for you to leave a gap so that you don't get the metal-to-metal corrosion that even happens with the same metal.
Yep. We've got the durability tool, which has those steel durabilities where you can set your climate. Some marine you mentioned before, so we can set that.
Now, a lot of people in this group, you're all getting to know me because of tools, which is great. But when I cut a lintel on site, I always cold galed the end. I don't know why, whether I was told it. I just always thought, well, I'm breaking the coating that this product was made with. And so all of these decisions with claddings, it's really, really important. Ideally, what we want to do, because we're not making mistakes, we're not putting up with 40 products that should never have been sold to us. And if there's a product failure, and I am seeing, and I'm talking to lots of contractors, I'm saying throw it back to the contractor, throw it back to the supplier as early as possible so that they get used to giving us products that don't fail. But if we install a product properly and we minimize and we select a product with minimum maintenance, it's a win-win for everybody.
Yeah. Okay. I think that's about it. Mark, g'day. I missed Design Matters off. Yep. I can reply to that, Mark. Yep. Cool.
So this has been almost it's more informative. It's just a chat. It's a chat about what's possible, because everybody in the food chain understands the science of drainage, understands that cladding is the skin on a building. It's our latex pants. Okay, we can go out into the rain and there'll never be a problem. So if we get, but it's really now passing on this knowledge to everybody downstream, especially designers who should just say, we want the cladding, we want a dry building. Cladding must be in accordance with compliance standards, and tools is the best way to explain that.
Excellent. Thank you, guys. Thank you all. Next week, I've forgotten what we're talking about next week, but we'll be doing another similar session. Do you know, got that handy, Jerry?
Oh, I haven't got the list, the calendar list, but
so we've got a calendar. We'll be doing a little bit of this every week, focusing on a different aspect. If you've got some requests, let us know. Otherwise, we hope to see you next week at the Tool Shed. Thank you, everyone, for joining us.
Thank you, everybody.
Cheers. Bye for now.
See ya.